So here we're asked to consider the curve y equals some function of x, which is a quadratic, and we need to find the average value of that curve between x is 1 and x is 3. So we have an equation for average values. So that's what this is, the average value of y. Alright, and that's the equation there. So this integral part, what that is doing is calculating the area under the curve between A and B, the extents of your domain. And then this part here, B minus A is like the length of your domain. So by dividing by it, which is what 1 on B take A is doing, essentially you're taking the area under the curve, dividing it by the length of the region, and what you should be left with is then the average value of the curve over that region. So we need B and A, which we can get directly from the question. So as we said, they're just the extents of your region of interest. So A is going to be the smaller one, so 1 in this case, and B is going to be the bigger one, which is 3. So let's substitute in. And we have y that was given to us. Alright, so we can do a little bit of simplifying. So 1 on 3 minus 1 leaves us with just 1 on 2. And then we can probably just jump in straight away and integrate this. So remember, for these polynomials, all we need to do is add 1 to the power and divide by the new power. So we're going to get 3, which is our constant, stays out the front, add 1 to the power, so it's going to be to the power of 3, and divide by the new power, so divide by 3. The next one, 4 stays out the front, add 1 to the power, so this is 1 to begin with, so it becomes 2, divide by that new power, which is 2. This one, if you apply that rule, you're going to end up with 1. This is originally x to the 0, so you add 1, it becomes x to the 1, and divide by it, so divide by 1. And since we have a definite integral this time, we carry the bounds over with us. We don't need the plus c term. So let's clean this up. So there's a half out the front. We've got 3 divided by 3, so they cancel. We've got 4 divided by 2, so that just leaves us with 2. And that there just simplifies to x. So now what we need to do is substitute in our bounds. So we start with the big one and then take away when we sub in the small one. So we've got this big half that I'm going to leave out the front. So subbing in the 3, we're going to get 3 cubed plus 2 times 3 squared minus 3. Take away, sub in the smaller one, so 1. So 1 cubed, 2 times 1 squared, take 1. So now we just need to evaluate what this is equal to. So we've got 3 times 3 is 9, times 3 is 27. We've got 2 times 3 squared, so 3 squared is 9, times 2 is 18. Minus, so 1 cubed is going to be 1, 2 times 1 squared is going to be 2. So we've got plus 1, minus 1 in the bracket there, so they're all going to cancel out. So it's a half, 27 plus 18 minus 3, we've got a double negative here, which is plus 2. So if you put all of this together, it ends up just being the number 40, and then dividing it by 2 leaves you with 20. So that's going to be the answer there for the average value of the function between x equals 1 and x equals 3. Now, of course, if you have some software, you can verify this just by doing a little check of the graph. So obviously, if you don't have that, you won't be able to do this check. But this here is like the graph that I pulled from Wolfram Alpha of that function. So what we were looking at was the value from x equals 1, which is this point here, up until x equals 3, which is this point here. So we figured out the area under the curve, that was the integration part, and then we divided by the length of the region, which was 3 take 1, or too long. Okay, so doing a little check, we can see that this is on the positive side of the graph, as opposed to being down here, which is on the negative side of the negative side of the x-axis. So that tells us we should have ended up with a positive value for the area under the curve, and as a result, our average value, if we drop a line through here somewhere, maybe the average is somewhere here. It's a bit hard to tell off this graph since the scale is quite rough, but we ended up with a value of 20 for being our average, and that looks pretty reasonable with this small sketch. So that's all there is for this video, and I'll see you in another one.